We are moving on to section 7.1, where we're going to be reducing rational expressions. I'm sorry that I don't have the live version of this, but I forgot to hit the record button last night during class. But rational expressions are expressions that are written as the quotient of two polynomials. We've actually been talking about polynomials in chapter 5 and chapter 6. In chapter 5, we were simplifying polynomials. In chapter 6, we were factoring polynomials, and we're going to be able to need both of those skills here as we move on to chapter 7. For our first example, we want to state the excluded values. And the issue here is that if you remember when we talked about fractions earlier in the semester, we cannot divide by 0. That's not how you spell divide. We cannot divide by 0. So what that means is, when they ask us this question, really the question they're asking us is, when does the denominator equal 0? That's really what they're asking. Because if you remember back earlier in the semester when we would try and evaluate, and we're going to do that in a couple minutes here also, but when we would evaluate a function at specific numbers, they would say, oh, what does this function equal when x is 5? Or what does this function equal when x is 2? And we would replace the x's with those numbers that they gave us. In this case, when we're talking about excluded values, we're finding numbers that we are not allowed to put in to the function or into the expression because they're going to make this fraction undefined. So that's the idea. When we divide by 0, a fraction is undefined. So this question is really asking us, when does the denominator equal 0? So that's what we're going to do. We're going to take this denominator, 3x squared plus 5x, and we're going to try and find out when does it equal 0. Okay? Now, in order to do this, we want to factor. That's why we had to do chapter 6 before we did chapter 7. So we want to factor this. Notice it only has 2 terms, and really always the first thing we should look for is a greatest common factor. So in this case, we can factor out an x. And what we have left inside the parentheses is 3x plus 5. Now at this point, we're going to use a fact that we have known since very early in our math lives. And that fact is, if you take any number and multiply it by 0, the answer is 0. So looking at this, x times 3x plus 5, hopefully we recognize if x is 0, then x times 3x plus 5 will equal 0, because this part right here will be 0. And 0 times 3x plus 5 we know should be 0. Also, if if 3x plus 5 equals 0, then x times 3x plus 5 will equal 0, because this part is a 0, and x times 0 will be 0. So because of those two facts, the way we're going to find out when that product equals 0 is we're going to say, well, if x equals 0, that's going to make that product equal 0. Also, if 3x plus 5 equals 0, that's going to make this product equal 0. And I'm talking about this product right here. So this one is already solved. We don't have to do anything with that. The second one, we have to solve for x. To get the x by itself, we're going to subtract 5 from both sides. This is taking us back to solving equations from earlier in the semester. So then we have 3x equals negative 5. We divide by 3, and we get x equals negative 5/3. So this negative 5/3 is an excluded value, and 0 is an excluded value. And so again, what that means is, if I was, as the teacher, asking you to evaluate this function or this fraction at certain x values and to substitute, I would not be able to use 0, and I would not be able to ask you to evaluate when x is negative 5/3, because those two values will make this function or this fraction undefined. So that's what it means when we state the excluded values. Now in class, there was some question of, is 0 always going to be one of the answers for the excluded values? And I said in class, no, that's not going to be the case. So I used this example, 327, and we said, okay, let's add 326b, and we're going to use this fraction, but we're going to state the excluded values again. Okay, so remember, the issue that we have is our denominator, x squared plus 6x plus 8, if that equals 0, that's going to cause problems for us, so we have to throw those values out. So once again, we're going to try and factor this, because we need to have factors to find these excluded values. So we're going to take the 1 in front of the x squared and multiply times 8, and get 8. And then remember, because this is a positive 8, that tells us that our signs of the numbers we're looking for are both positive or they're both negative. Once we know that, then this sign tells us that both of these have to be positive. So they multiply together to be a positive 8, which means they have the same sign, but then they add up to be a positive 6, which means they both have to be positive. So we could try 1 and 8. That adds up to be 9, so that's not the right choice. 2 times 4 equals 8, and that one does add up to be 6. So remember, we come over here, we do x squared plus 2x plus 4x plus 8. And then we're going to factor by grouping. And from the first group, we can factor out an x, and and what we will have left there is x plus 2. In the second group, we have to factor out that sign, whatever it is. In this case, it's a plus sign. And then we can factor out a 4, and dividing out the 4, we will have x plus 2. And so our factors will be x plus 2 times x plus 4, and we want to know if that ever equals 0. And so again, using the same logic, if x plus 2 equals 0, that will make the product equal 0, because it'll be 0 times x plus 4. Also, if x plus 4 equals 0, that's going to make the product equal 0. And then we subtract 2, so x equals negative 2 is going to be one of our excluded values. Here we subtract 4, so x equals negative 4 is going to be our other excluded value. So if we were doing the excluded values for that fraction, the excluded values would be negative 2 and negative 4. So no, it's not always true that 0 will be an excluded value, but it is always true that we take that denominator and set it equal to 0 to find the excluded values. So what's actually going on here in example 327, though, is we are going to evaluate this fraction when x equals negative 6. And if you remember, all that means is we're going to take all the x's and we're going to replace them with negative 6's. So we're going to have negative 6 here, negative 6 here, and negative 6 there. Everywhere we see an x, we replace it with a negative 6. So here's where we have to be a little bit careful. Negative 6 squared means negative 6 times negative 6, that is 36. And then we have minus 4. In the denominator, we have negative 6 squared again, so once again, that is 36. Plus 6 times negative 6 is going to be negative 36. And then we have plus 8. In our numerator, 36 minus 4 is 32. 36 and a negative 36 are going to cancel each other out, so we have 8 in the denominator, and then when we take 32 divided by 8, we're going to get 4. So that is our answer for evaluating, and again, we've evaluated at various times throughout the semester, so hopefully that one makes sense. You just replace all the x's, even though it's a fraction, you just replace all the x's with negative 6's. Example 328, we're going to reduce this, and we did this in chapter 5 when we were working, chapter 5 when we were working initially with our rules for exponents. And if you remember, this means 15 times x to the 4th times y squared. And on the bottom, it means 25 times x squared times y to the 6th. And when we have these things all multiplied together, each of these is a factor, 15 times x to the 4th times y squared. Those are all factors, and on the bottom it's the same thing. So we can deal with the numbers and the x's and the y's all individually. So if we look at the numbers, we were able to divide both of those by 5, and that's going to give us a 3 on the top and a 5 on the bottom. And then when we look at the x to the 4th and the x squared, if you think about canceling, you've got 4 x's on the top and 2 on the bottom. When you cancel them, you're going to have 2 x's left on the top. And then with the y's, you've got y squared, so you've got 2 y's on the top, and y to the 6th means that there are 6 y's on the bottom. If you think about canceling those, you're going to end up with 4 y's left on the bottom, and that's going to give us our reduced fraction there. But again, the important thing is these things are all multiplied together, and that's very important because that's going to lead us to our next problem. In 329, we're reducing, but notice we don't have things multiplied together here. In our denominator, we have things that are subtracted. So before we can do anything as far as canceling, we have to make them multiplied together. So we're not going to multiply 8x squared times 16 because that's not what it tells us to do. We're supposed to subtract them. But what we are going to do is we're going to factor the 8x squared minus 16. So notice, greatest common factor, we can factor out an 8. And then we will have x squared minus 2 left inside the parentheses. Notice that our parentheses can't be factored any further because it's only 2 terms, and the only option we would have there is difference of squares, but 2 is not a perfect square. So that's all the factoring we can do. But once we've done that factoring and we have 8 times this parentheses, we can reduce the numbers, the 28 and the 8. So we can reduce both of those by 4. So 28 divided by 4 on the top is going to be 7. 8 divided by 4 on the bottom is going to be 2. And then we can't do anything with this x squared minus 2. We just have to leave it alone. So that is going to be our answer for reducing that. Okay, so again, just to emphasize, because of this minus sign, it would be wrong if you tried to reduce the 8 with the 28 here or the 8 with the 16 here. That would create problems for you, and it would give you the wrong answer. Just as a quick illustration of that, and I think I did this something like this in class, but if we had 6 plus 3 and then 6 plus 2, well, we know that that is 6 plus 3 is 9 and 6 plus 2 is 8, so that would be 9 over 8. But if we looked at that and thought to ourselves, oh, I see 6's, I'm going to cancel them out. Even if we cancel them to be 1's, that would give you 4 on the top and 3 on the bottom. And you can see that's a totally different answer than what it actually should be. So if you have addition or subtraction involved, you cannot do canceling. On the other hand, if you had 6 times 3 and 6 times 2, that would be 18 on the top and 12 on the bottom, which would be 3 over 2. And then if you think about canceling them with the multiplication, cancel them to be 1's, you'd have 1 times 3 and 1 times 2. And you can see in that case, they are the same. So it's a very important thing to remember is if you have addition or subtraction, you're not going to be able to cancel. If you have multiplication, you can cancel. So we always have to look for factors, which are things that are multiplied together. 330, we want to reduce this one. We want to factor first. So notice in our numerator, look for the greatest common factor. We can factor out a 3. And then inside the parentheses, when we divide out that 3, we will have 3x minus 1. In the denominator, we can factor out a 6. And then when we divide out that 6, we will have 3x minus 1 again. And notice this time, 3 times 3x minus 1 and 6 times 3x minus 1. If you look at the numbers first, they can reduce because 3 goes into both of those. So you're going to end up with 1 on the top and 2 on the bottom when you divide 3 by 3 and 6 by 3. And then notice in this case, since these are the same, top and bottom, they can cancel out to be 1s. And so on the top you have 1 times 1, which is a half, or which is 1. And on the bottom you have 6 times 1. And we had already reduced those, so we get our 1/2. Sorry, on the top you'd have 3 times 1. On the bottom you'd have 6 times 1. And then when we reduce that like we did before, you get 1/2. So again, the only reason we can cancel these is because they are exactly the same, 3x minus 1 and 3x minus 1. If there's anything different about them when there's adding or subtracting, we can't cancel them. So adding or subtracting, you have to cancel the whole thing or you can't cancel anything. Looking at 331, and we're still doing the same thing. So we want to try to factor. Notice that this x squared minus 25, that is x squared minus 5 squared. So that fits our pattern of difference of squares. And when you have difference of squares, it factors to be the first thing plus the second thing and the first thing minus the second thing. So looking at that top, I'm going to put this down here. X squared minus 5 squared becomes x plus 5 times x minus 5. And again, the parentheses means that we are multiplying. There's a times sign in between there. For the denominator, let's go ahead and factor that. We're going to take 1 times 15. 1 times 15 is 15. And it is a positive 15. So that tells us either both signs are positive or both signs are negative when we start looking for these factors of 15. And then this tells us that they both have to be positive because they're going to add up to be 8. So looking at these, you could have 1 and 15, but that adds up to be 16, so that's not 8. 2 doesn't divide evenly into 15. 3 divides into 15 5 times, and that will work. 3 and 5 is 8. So we write this out. X squared plus 3x plus 5x plus 15. And again, as I've mentioned several times in the past weeks, that works because 3x plus 5x is 8x. Then we want to factor by grouping. So when we look at this first one and we group them, we can factor out an x, and we will divide that out, and we'll have x plus 3 left inside the parentheses. We have to take out the plus sign, and then we can also take out a 5. So dividing by a 5 gives us x plus 3 again. So we know that that would be x plus 3 as one of the factors and x plus 5 as the other factor. So let's go ahead and put this in right here. And again, notice these are multiplied. These are factors. So when we look at this, we can cancel any factors on the top with any factors on the bottom as long as they're identical, so they don't have to like line up vertically. But notice this one can cancel out with this one. And when we cancel them, they do turn into 1s, which usually doesn't matter because 1 times x minus 5 is going to be x minus 5. And then 1 times x plus 3 is going to be x plus 3. And that is as far as we can go because x minus 5 is not exactly the same as x plus 3, so we can't do any canceling there because of the plus and the minus. Now, one thing I will mention is you don't actually need these parentheses in your answer because everything is, it's only one factor. You could write it like this and like this. But I would suggest maybe keeping it just to emphasize to yourself that that thing is grouped together, so you can't cancel it unless you can cancel the whole thing. And also, when you're typing your answers into the computer, it may make it easier for making your fraction if you put them in parentheses. Not sure about that, but I think that may be helpful for you. Okay, once again, just to emphasize, it is important. It's probably one of the most important things because it's one of the most important, it's one of the things that people miss most often, but it is important to remember that you cannot reduce terms. Remember, terms are things that are added or subtracted with each other. You can only reduce factors, which are things that are multiplied by each other. This means that if there are any plus or minus signs between the parts that you're trying to factor, you cannot or that you're trying to reduce, sorry, you cannot reduce them. So for instance, to go back to this problem, it would be wrong to try to cancel these two because that x squared minus 25, because of this minus sign, that is connected together. You can't cancel the x squareds until you find some other factors. So that's why the factoring part is going to be so important to us in this unit. You've got to factor first, and then after you factor, then if you have, excuse me, then if you have common factors, then you will be able to reduce. So again, you can't reduce terms, you can only reduce factors, or you can only, I should say, maybe you can't cancel terms, you can only cancel factors. So if you've got plus or minus signs in there, you've got to cancel out the entire thing or nothing at all. And that's the end. You've got 9 problems. Again, excluded values means that your denominator can't be 0. And then the rest of that pretty much was, I guess we had an evaluation problem, just replace the variable with the number that they give you. And then the rest of them were all factoring and canceling to try and reduce those fractions. So hopefully that's helpful. And again, I apologize for it not being the live version because I forgot to record it. But hopefully this will work out for you, and hopefully I remembered to put in all those questions that people had asked, or at least a good chunk of them.